In the last session, we learnt about latitudes and longitudes, and we learnt about their utility. And in this session, we shall look at what is this international date line and how it is important for us for our day-to-day activities. Let us look at this particular question. It gives you three statements. The first statement is the standard time is regulated by the UN and international date line has been moved to the right of Samoa by UN. The second statement is on the basis of Earth's rotation, all the locations on the Earth will be on the same day and date an hour before the exact midnight if the international date line were to be a straight line and free from political decisions. The third statement says that the International Space Station has a time zone of UTC plus 12, that is Coordinated Universal Time plus 12 hours as the time zone for those astronauts who are on the International Space Station. Which of these three statements are correct is the question. Those of you who are attempting this question, please pause the video and try to attempt the question. Those who have got correct answer, you are really good at concepts. Now let us look at what are these concepts which are behind these three statements. Given these three statements, remember that there are two very significant events that must be recalled in order to understand what this international date line is and how it is so important for us. One is the historic event which occurred in history, and the second one is the more recent one. What is this historic event? You know, the importance of international date line can be attributed to the very historic problem that we have faced, which is called as Circumnavigator's Paradox. It is called as Circumnavigator's Paradox. What is the Circumnavigator's Paradox? Here, when travelers are going westward, they would find upon returning home that one more day than they thought had elapsed. The eastward travelers have found that they seem to take one day less than they recorded upon reaching their destination. So the Circumnavigator's Paradox was noted by many explorers, and some of the explorers that we learned in the previous sessions. For example, we knew about this person named Ferdinand Magellan, and also there was one more historic personality named Francis Drake, whose westward circumnavigation of the globe has clearly found this paradox called Circumnavigator's Paradox. There is second historic event that we must recall, which I told you is the more recent one. Look at this particular picture. It is the flag of a southern Pacific island nation. In this, you see that there are two parallel waves of streams which are flowing, which resemble the Pacific Ocean, and you have a sunrise, and then you have a frigate bird flying over this sunrise. This reflects a nation which is very tiny one, however, which made a lot of news because of its one decision that it has made during the turn of the millennium. Here, this particular Pacific island nation that I am referring to is known as Kiribati. Generally, it is written as Kiribati. It is referred to as Kiribati. On the day of 31st December 1999, the entire world media was focusing on one single IT problem called the .com problem due to the turn of the millennium. However, there was one less but very important issue that hasn't received much media attention is this particular fact. Which region marks the clock ticking for the December 31st night? That is, which is the nation or which is the area which gets this particular digits on its clock for the first 0000 AM. So many South Pacific islands were jockeying for this particular position along the international date line in a struggle to be the first place on Earth where each calendar day begins and each new year too. So each contestant wants to be able to say here that the year 2000 has started in this particular place. So the tourists were also trying to throng into these places, and they were also trying to witness the sunrise first than many other people in the world. So the islands which were trying to promote themselves as official millennium sites for many. You had these islands named the Chatham Islands. If you look at this particular picture, you can know you have these islands named Chatham Islands, which are lying east of New Zealand. Then you have also what is called as Tonga. Then you have what is called as Fiji. Then you also have the nation named Kiribati. These 4 islands were trying to promote themselves as the regions where the first sun rays have fallen at the turn of this millennium. And this was so competitive that each and every one started attracting the tourists. At this particular time, when no one has paid much attention to whatever that new sharp zigzag, the international dateline was there, and what its implication would be for the party of the millennium. You have seen the flag of this nation named Kiribati. This Kiribati as a nation is spread across an ocean area covering not less than at least 5 million square kilometers. Number 1. Number 2, it consists of some 33 small atolls, out of which you find that 20 are really inhabitable. And number 3, these atolls have constituted 3 fundamental islands. One is known as Gilbert Island, the second is known as the Phoenix Island, and the third is known as the Line Islands. These 3 islands make up the Kiribati as a nation, as an island nation. Number 1. Number 2, apart from this, you find that this Kiribati and the Line Islands in this Kiribati are located as far as 30 degrees east of the 180 degree longitude line. So for many years you find that this international dateline that was chosen, which for historic reasons bisected the island republic into 2 equal halves, and this has been viewed as an annoying economic nuisance by this particular island tiny nation. So the western part of the republic was always 24 hours ahead of its eastern part, and because of this, geographically you find that both of them were struggling to function together. So geographically, Line Islands, if you observe, they lie almost directly to the south of the US islands of Hawaii, and hence they should logically be in the same time zone of what? Hawaii Islands. But this is not the case because the international dateline here has been made a zigzag line but not a straight line. So because of this, it goes around quite a bit, and over the years, whatever the problem that was faced by Kiribati was solved at the turn of this millennium. How? They have decided to shift the international dateline towards their eastern border from where it was going midway through this particular country. So when they have shifted this the international dateline to match its eastern border, they find that the entire region now brought under a single time zone. To ensure that they celebrate this particular occasion on the turn of the millennium, they have also named a particular island in this particular Line Islands, that is the Caroline Island, as the Millennium Island. This became a very, very historic decision. Now, in the same lines, you find that various other nations have also started claiming for their authoritative statement that they were the ones who have received the sun rays first on their regions. However, officially it is now clear that it is the Kiribati which has received these sun rays first because of their decision that the international dateline must be moved ahead towards its eastern border. So for inhabitants of this eastern part of Kiribati, particularly the Line Islands, this measure meant that 30th December 1994, which was a Friday, would be followed by the 1st December 1995, which would be Sunday. That means they have skipped one important day from their life, Saturday, and hence This decision of shifting this international dateline made a lot of news at the turn of millennium. It is also said that on this day of 31st night, Kiribati has felt a lot of shortage with respect to beer, and it had to make a lot of arrangements for its resupply again. So as things stood now, clocks on Kiribati line aligns stroke midnight at least 1 hour before clocks anywhere else on this particular globe. Having looked at those two important events pertaining to some fundamental phenomena related to Earth, where we have looked at one, the Circumnavigator's Paradox, and the other, the political decision of a particular nation leading to criticism from various neighboring nations, we shall now look at this fundamental concept called international dateline and how it has its importance with respect to our day-to-day activities. Before going into it, please remember that this entire concept of international dateline is dependent upon the concept of Earth's rotation. We know that Earth takes 24 hours to complete its one single rotation around its own axis. This is the animation which shows that. In this animation, before start of this animation, let me make clear some fundamental assumption. We know that this particular white line is at what is called as midnight point. Crossing this midnight hence takes us to the immediate next day and next date. That means here let me assume that we have already completed one complete rotation by the time we reach this particular midnight point on this white line, and every particular location on this white line is now at this point of midnight, meaning whatever the points which are lying above it, assuming within this green region, they are about to reach this point of midnight. That means they have already elapsed nearly one complete revolution. And whatever the points which are lying below this white line, they are about to start their first revolution, meaning whatever the date that we find at this particular juncture on this white line, there is a shift in the date. And whatever the point which is lying below this white line, they are still in the previous date. They have just started their previous date. That means whatever the line, whatever the locations which are lying above this white line and whatever the locations which are lying below the white line are clearly differentiated by these 24 hours. This is what you have to remember, meaning this white line marks the shift in the date. The points which are lying above it will be entering into the immediate next day when they cross the midnight point. The points which are lying below it, they have just started their day. That means they are one day behind this particular point of white line. Given this fact, it is explaining you what is called as international dateline. Now look at this particular animation. This entire region now crossing this midnight point, it is now getting to the sunrise point, and then it gets to what is called as noon and then sunset. This entire rotation now is taking 24 hours, and these regions which is now lying blue, that is out of this green region, are about to elapse their rotation, complete their rotation and enter into the new date. Now you look at the regions in the red zone. All the other regions, they have elapsed their single rotation and they are entering for their next round of rotation. By that time, these regions which are in the red zone, they have already elapsed their rotation and they have crossed this midnight point. That means they are of next date and the green zone is of the previous date. This animation hence is giving you the picture of how the rotation is affecting the change in the day and date respectively. Having understood this, this white line then hence can be called as the meridian or the line which is serving as a fundamental purpose. It is clearly giving us the locations where this 24 hours of time that the earth takes to complete one single rotation is being demarcated by this particular line. this particular line is not on earth, it is an imaginary line. This imaginary line that we have considered has this fundamental purpose to do. This is a line which is drawn on the surface of the earth that runs from South Pole to North Pole, and it slices through the center of the Pacific Ocean. That means it is separating two consecutive calendar days. This is its fundamental purpose. Secondly, the international dateline is located halfway around the world from prime meridian 0 degree longitude. That means it is matching with approximately 180 degree east or west of Greenwich, London, UK, the reference point of all the time zones that we have calculated earlier. Number 3, as we are using this as the line of demarcation for the days, consecutive calendar days, we also call it what is called as line of demarcation. Line of demarcation. So this is the fundamental purpose of the international dateline. Now you go back to the problem of Circumnavigator's paradox. When he has been to the western side of the location from which he is traveling, remember that he is getting 1 day more than what he has elapsed, because going west, as we have seen in the animation, is going to add a single day completely, and going towards east will have to subtract 1 single day. And because of this, those who have gone the eastward, they found that they have taken 1 day lesser than what they have actually elapsed, and this has resolved the entire riddle that we used to face earlier. Similarly, whatever the political decision that the Kiribati and Tonga have taken in order to change their standard meridian in terms of the time zone that they wanted to enter into, here what they did was they have redrawn this international dateline in such a way that it marks the eastern boundary of this particular nation called Kiribati, and because of this, the entire region has been brought into one single time zone. And because of the shift of this international dateline towards east of the Kiribati, because the Kiribati lies somewhere like this, towards east of the Kiribati, we find that suddenly it has to add 1 whole day into its calendar, and because of this, it had to skip Saturday, and then it had to directly enter into Sunday on January 1st, 1995. As we have seen here, it is not a straight line that we see with respect to international dateline. It zigzags. It zigzags because it had to avoid all the political and country borders, such that it did not cut all the countries which are falling in its particular traverse into half, and this would create a lot of political and economic issues that we have seen earlier with respect to what is called as Kiribati. So the international dateline can be placed anywhere on the world. There is a possibility. However, the most convenient one was found to be 180 degrees from the prime meridian, because 180 degree meridian was mostly running through the sparsely populated the Central Pacific Ocean, and hence this was chosen at the International Meridian Conference that held in 1884 in Washington, which was attended by 26 countries. In spite of this name that we see here, international dateline, the expression international here is some kind of misnomer, because there is no force in any international treaty or law or agreement that implements this particular international dateline. That means it is one of the very few standards which was embraced voluntarily by many nations in globe. So the international dateline is not enforced by any international organization such as UN. So whatever the enforcement which is occurring is purely on voluntary basis by each and every nation. Number 3, the IDL, that is international dateline, is crucial for certain purposes. Number 1, the global interconnectivity. Number 2, instantaneous communication. Number 3, for measurement of time. And number 4, it also is important for consistent international databases, such that there is no inconvenience with respect to commerce, there is no inconvenience with respect to politics. So as a result, there have been numerous changes in the location of this particular line in the past, and today the line hence is not straight but it is zigzagged. Its line in some parts even extending as far as the 150 degrees longitude line. If you look at this particular border, approximately it is 30 degrees away from this 180 degree meridian. That means having this much of shift has been made possible because of the political decisions. So the international dateline has not been static. Over time, it's a shift in time and place occurred owing to local interests and political affiliations. So one notable shift here, if you look at its evolution of shift, is the shift of Philippines. Philippines have made some adjustment where prior to the present position, these Philippines islands had been to the east of the line. Now they felt that this has to be shifted because of its own political decision. It was hurting its commercial interest. It was hurting its commercial interest because the Spanish travelers used to have their journey towards this Spanish colony called Philippines was through South America. So it was convenient for them to have Philippines within the towards the west of the international dateline. However, during the early 1840s, we find that the commercial interests of Philippine Islands turned increasingly away from South America because South America started emerging independent from Spain, and hence its trade started nearing with the Malay Peninsula, the Australia, and also China. So they have decided that for facilitating growth of this new trading and communication links, they felt that they have to align with their own Asian timeline. Hence, they have shifted themselves towards east of, they have shifted the international dateline towards the east. And secondly, we find that this particular shifting has been done even by Alaska. Alaska used to be with Russia. However, this was sold to USA in 1867, and when USA bought Alaska in 1867, this line of international dateline was moved to the west of it. Hence, we find that Alaska has been given a separate time zone by USA, and it is now lying east of international dateline. Along with this, we have already studied about Kiribati, which is the island territory. Along with that, Tonga, they have also shifted their the international datelines towards their eastern boundaries. And apart from this, we know that in 2011 there was another island nation named Samoa, which has shifted the international dateline, whereby it has shifted this international dateline towards the other side of the country, and hence it has advanced the country from one particular time zone to another particular time zone. Apart from this, we also know that there is another island nation called Tokelau, and this Tokelau also has advanced its standard time from one particular time zone to another particular time zone by riddling with the international timeline. So these are the various other countries which have riddled the international time zone and international dateline, and because of this we find that international dateline is not straight but it is in a zigzagged manner. So having understood this, if there is any point east of this international dateline that should have been on the previous day, and if there is any other point on the west of international dateline, you find that that would be already a day ahead of the point which is on the eastern side of the international dateline. Here, when this international dateline has been tweaked by many such island nations, you observe that even though the point which is at the just east of the international dateline is behind these points, the countries which are lying within this international dateline where it has got this zigzag shape, they are already in a situation where they have elapsed a complete day. That means even though they are lying geographically east of this particular point, you find that because of the tweaking of this international dateline, they are already advanced in terms of their day and date. Number one. Number two, here you must also observe that it is not just the day and date which gets advanced because of this tweaking. It is also importantly the time that you must consider, because of which you find that the day and date are getting advanced. So what time zone that they must fall into is very, very significant. Probably in the previous session I haven't discussed on the basis of on what basis we choose a particular time zone. Here let me do it briefly. You know that any particular complete rotation that we look at will have an elapsation of 360 degrees in terms of circumference, and it is taking 24 hours, meaning for every 15 degrees we find that there is an elapse of 1 hour. That means if I move 15 degrees away from a particular point, there is a difference of at least 1 hour. When I said that the eastern boundary of Kiribati is lying as far as 30 degrees away from the international dateline that we are seeing here, meaning it is 2 hours away from the international dateline. We know that international dateline marks the boundary of this 24 hours. When it is 2 hours away from the international dateline, it means it is having a time zone which can be comfortably placed as Greenwich Mean Time plus 2 hours. That means it is having a time zone of 26 hours ahead from the points which are just lying east of international dateline that I have pointed out here. This tells us one very important fact. In spite of the fact that it has to be a demarcation only of 24 hours, it is in reality much more than 24 hours by at least 2 hours more than whatever the time that Earth takes for its complete one rotation. So the general rule is that we choose a meridian as standard meridian if it is divisible by either 15 degrees or 7 degrees 30 minutes, such that difference can be either 1 hour or 30 minutes, which will be feasible for us to have all the data to be compiled. Number two. Here, when I was referring to the time zone of this particular nation called Kiribati, which has zigzagged the international dateline, here you observe that from the zero meridian, where it is 12 noon now, if you come to the 180 degree meridian, you find that it is 12 in the midnight. That means there is an additional 12 hours that you have to consider. That means it is GMT plus 12 hours. However, as we have seen this shift of international dateline, because of which we find that this particular meridian is going through it, 150 degree west meridian is going through the Kiribati, and the shift of dateline hence adds 2 more hours here, and hence we have what is called as GMT plus 14 hours as the time zone of Kiribati. So because of this tweaking of the international dateline, we find that it is the Kiribati which celebrates the New Year first, and the region named American Samoa celebrates the New Year last. And this was what happening on the day of turn of millennium, and hence the political decision of Kiribati has proved very vital for it, because of the fact that there was a lot of surge in its tourism industry. And if you observe here, on the day of any particular time, that is between 10 a.m. and 11:59 a.m., you observe that there are 3 dates on the calendar which are in use at the same time on Earth. I repeat, every day between 10 a.m. and 11:59 a.m., you find that 3 different dates on the calendar are in use at the same time on Earth because of the different time zones that we have. If I look at this particular time, 10:30 a.m., at this particular time of 10:30 a.m., you have on this day of April 11th, you have the date of April 10th in American Samoa, because it has this time zone of what is called as Greenwich Mean Time minus 11 hours. And because of this time zone, if I have to remove these 11 hours, it is 11:30 p.m. on April 10th. Similarly, if I take into consideration New York, which is 4 hours behind the Greenwich Mean Time, that means it is 6:30 a.m. in the morning on April 11th again. And again, if I look at Kiribati, as I told you, which is the Greenwich Mean Time plus 14 hours, it is already 12:30 a.m. That means we have already come to April 12th. This is how on a particular single day between 10 a.m. and 11:59 a.m. you find that there are 3 different dates that are in use at the same time on Earth. This fact has to be remembered forever. Apart from this, we find that the expression called Greenwich Mean Time has been replaced by what is called as Universal Coordinated Time. This replacement has been done because of the invention of what is called as the atomic clocks. These atomic clocks take into consideration even the minor changes in the geology of Earth, and because of which there might be variation in the Earth's rotational speed. For example, if you look at the fact that the glaciers melt, and because of this there is a transfer of mass from higher latitudes towards the equator, the law of conservation of angular momentum tells you that there is a requirement of reduction of the spin rate to compensate for this redistribution of mass, and because of this there must be some redistribution, there must be some change in the rotational speed of the Earth. Similarly, when the scientists have tried to estimate the earthquake of 9 magnitude that occurred in Japan in 2011, which has shifted enough mass away from the equator to shorten the day by almost 1.8 microseconds. All these differences, where there is a difference by a fraction of even a second, depending upon the geological perturbations that we have tried to understand now, the atomic clocks consider even these changes, even a simple leap second that has to be added as a correction, and hence UTC would give us exact time than Greenwich Mean Time. The Greenwich Mean Time is an average time system based upon the telescopic observations which have been made from the Greenwich Observatory. So UTC, when it has been synchronized to GMT, it even takes into account of these slight variations which are possible in the Earth's rotation rate because of the various changes that we witness in the geology of the Earth. So this is how the universal coordinated time has come into being. This, as I told you, this universal coordinated time would give you the exact time. You must remember one more very important point. Going away from this general rule that we will choose a standard meridian for calculating our standard time falling in a particular time zone, the general rule tells us that I have to choose the meridian which is divisible either by 15 degrees or by 7 degrees 30 minutes. However, there are certain nations which have chosen those meridians which are not divisible by 15 degrees or not divisible by 7 degree 30 minutes. These lead to what is called as fractional time zones. There are 16 such nations which have these fractional time zones. For example, I was referring to what is called as Chatham Islands, which was also competing for having the claim that the sun rays on the eve of turn of the millennium have fallen first on their islands, which is east of the New Zealand. These Chatham Islands, which is almost 800 kilometers east of New Zealand, they have set their clocks to what is called as UTC plus 12 hours 45 minutes. And because of this, we find that there is a creation of what is called as fractional time zone. As I told you, these fractional time zones have been chosen by them because they work best for them, since they utilize this time zone to use more daylight that is possible in a particular season. Keeping this in view, remember that the general rule that we follow has also been violated in terms of even choosing the standard meridian. Along with this, you must remember one more very important point, that is what will be the time reference that we will have once we are into space. Remember that the astronauts would be sent to the space from various locations. For example, you have this particular location named Baikonur Cosmodrome in Kazakhstan, and most of the time the astronauts would be flying to the International Space Station from this particular location, and there is hence lot of scope for what is called as chronological confusion because of the variation in the time zones, and hence it is no wonder that the International Space Station needs to be locked to a particular consistent time. Hence, here you must remember that the International Space Station is moving at a very astounding speed of 4.7 miles per second. That means 7.7 kilometers per second, which is almost 6 times faster than whatever the speed at which the bullet travels. When ISS hence makes one trip around the Earth, it is taking 90 minutes, meaning it is having almost 32 day and 32 date alterations for every 24 hours if you calculate. Hence, it is having 16 sunrises and 16 sunsets. So the International Space Station crew experience a sunset or a sunrise every 45 minutes. This will lead to further confusion with respect to having a consistent time. Hence, there is a need for having a consistent time. So ignoring whatever the complexities or complications that might emerge because of the Earth's rotation or the special relativity of Einstein that we must consider, keeping them away, if I look at time to have a particular standard, here hence there is a requirement to have a consistent time, and hence all the visits to the space will have one particular zone of choice, that is UTC plus 0. So there is no scope of having any other time zone than this universal coordinated time. Similarly, there was a confusion when the astronauts have visited the moon. When we celebrated the 50 years of the Neil Armstrong putting his foot on the surface of the moon, there was then this discussion again about the time zone that is being followed by the dwellers of the earth over the surface of the moon. You can here have lunar standard time. However, this lunar standard time and having it would be more interesting exercise in physics, but not for any practical purpose for us on earth. So in order to have a consistent time again, even for those astronauts who step into the moon, we will have what is called as universal coordinated time as the time zone. So the time zone on moon also will be the same as UTC time on earth. Right now, as you know, here on earth we have 24 hours to pick and 24 time zones. We have chosen UTC plus 0 as the time zone for various locations in the space too. Apart from this, there is one more concept that you must remember, which is called as daylight saving. This daylight saving is all about transfer of some time such that you will use the possibility of having more day for the purposes of your day-to-day activities. So there is a transfer of an hour of light to a time when it will be more useful. So they will adjust clocks during the part of the year that has a longer daylight period to correspond more closely with the modern pace of society. So USA has daylight saving time which begins on every second Sunday. Every second Sunday in March, and this will end with first Sunday of November. It has 4 time zones keeping aside the Alaskan time zone, Eastern Standard Time, which is at 75 degrees west. Then it has the Central Standard Time, which is at 90 degrees west, and then it also has Mountain Standard Time, which is 105 degrees west, and then it has Pacific Standard Time, which is at 120 degrees west. If you observe, all these are divisible by what? 15 degrees. So European Union also has its own daylight saving, where the summertime begins last Sunday in March and ends on the last Sunday in October with respect to this daylight saving. Apart from this, as I told you already, Chatham Islands, New Zealand and also Fiji do have their own daylight saving. However, they will have it during this summer in southern hemisphere, as they lie in the southern hemisphere. So during this particular time, their time zone advances to what is called as UTC plus 13. So except for the Chatham Islands, where this advancement of 1 hour will lead to another fractional time zone, which is UTC plus 13.75, because UTC plus 12.75 is its standard time. Look at this animation. This animation tells you that the region which is lying in this green color is on a same day and same date. If you observe that the white line is representing the shift of the date, and this animation tells you that when it is particularly on this line of UTC minus 11 time zone, when this white line which is representing international date line is on UTC minus 11 time zone, that is on this particular time zone, you find that the entire earth seems to be on the same day and same date for whatever the 1 hour which is possible between these two meridians, because this gives you the fact that it is 15 degrees apart from each other in terms of angular distance, which amounts to what in terms of time? 1 hour difference. So this entire 1 hour, it appears that the entire earth seems to be on the same day and same date. On everyday basis, it seems that this occurs, and it ends when the eastern edge of the next time zone, that is international date line, that is UTC plus or minus 12, hits midnight. At that time, a new day begins to unveil. So if you watch the animation again, you find that this is true by the fact that this red color zone, whatever that you are observing now, seems to be getting occupied with the same phenomena again at that particular time zone of UTC minus 11. The entire earth seems to be in the red color, that is the entire earth is on the same day and same date for that entire 1 hour of time that you are considering on everyday basis. However, as it has been explained, this is an ideal model because this is purely based on Earth's rotation. However, in reality, we observe that the possibility of having such a phenomena is almost negligible, because we find that the entire calculation of time now is based on whatever the ideal that we have in practice. Because of the various political decisions, the international date line has been zigzagged to the point where it's never the same day all around the globe. So in truth, it is for an infinitesimal instant we find that when ideal, that means the international date line hits midnight, we find that the entire earth appears to be apparently on the same day, but in practice it is never a possibility. This is what you must remember, and this is how there are possibilities of having various types of conceptual questions appearing from the international date line. After this bit long session, try to attempt this question. Here there are again 3 statements given. You have to identify the right answer. This clearly is based on whatever the concept that we have learned till now. Try to attempt this question. Post the answers in the comment section.